You know what? This is the second time I record this video, because the first time I did it I forgot to connect my low quality microphone. I will replace it in days, but I'm sorry for the audio quality, and that's why I don't make videos for more than 2 years. Okay, today we will I won't be doing live coding, but I will go through some code and I will explain some important concepts about assembly and about how if statement work and what is compare instruction and how it works and how to reverse it and how to bypass some fake security we will do. Let's take a look at some code. Let's vim main this simple C code that asks for a number and compare it with 10, and if it's correct it prints this message, else it will print this message. Let's compare and run it. Main1 gcc main.c 8 out 10 correct, 11 as expected. Okay, now let's take a look at its assembly representation. gcc using s parameter main.c vim main.s. okay, actually we don't care about all of this. This is the constant data section, and this is where the assembler is setting the stack frame of the main function. Each function has its own stack frame. It's a 16 byte one, and this code is important one. I will mark it. Here our 10, this is the y value, this is y. We are moving y to this address, base pointer minus 12, and it will stay there. Load effective address of lc0 to print the enter a number message, calling printf function. Then moving the base pointer minus 16 to rax, and then to store its value I think to no. I said no in Arabic, sorry. I forgot to say sorry about my language if you can't understand me well, because I'm not a native speaker. Okay, if there's something you want me to explain it further, ask me in the comment section. Now let's go back to the code. Anyways, here we are loading the address of lc1, which is the scanf parameter to scan for a decimal number, and we are clearing the EAX because I think this is the function call of scanf, the function code, not the function call, function code, and we call it, and the value of it can be the function code. Actually it's the return value of it, so I think this line is not important, but I will keep it anyways. Now the value is stored in EAX. We moved it to RBP to compare it with what? With base pointer RBP minus 12 that contains the 10, the y value. If the comparison is true, both are equal, we will not jump. We will continue and we will call a lot of effective address on the address of correct password message, which is lc2, and we will call bus string to print it. Okay, otherwise we will jump to l2 will cause long password to be printed out. Okay, why you are saying all of this? Because compare, we are comparing these two values, and if they are equal, we won't jump. because we have unconditional jump. That of course we can change, and this is the point. If statements are just like any single يعني oh shit يعني is a Arabic word too. Think of it as if in C code or C++. You can make it if not, and this is exactly the same. Jump if not equal, we can make it jump if equal, and we can even make it unconditional jump. Just jump, no matter what is the result of CMP instruction. We will make this jump if equal, and let's assemble the code and see what we will have. Static main.s sample, no such instruction y. Where is y? Yeah. The comment in JS assembler, the GNU assembler, the back end of GCC and G++ is not a semicolon. I don't know, I use NASM, so I used to make comments using the semicolon. Anyways, let's try again. Shit. Hold on, sorry. And now the execution should be as follows. If the input is 10, it will print wrong password, and otherwise it will print correct password. Let's see, 11 correct password, any number correct password, and if it's 10, wrong password. Okay, but you might be thinking, I won't be shipping the source code of my software with it, so nobody will ever be able to reproduce the assembly and edit it and do these things. You are right, but we will do it the hard way. You might be asking, all the things you are doing or you are saying have nothing to do with the title of the video, but bear with me, it will make sense. Now let's start the debugger, run out, and before doing this we must compile it again to reproduce a valid binary. This is sec one. gcc main.c, and now we can run adb, run edit out. Okay, I'm recording this part of the video for the third time because I'm using OBS as a screen recorder. The first time I was recording, and OBS has a feature, instead of capturing the whole screen, it only captures a single window, no matter what is on the screen, what is the screen is currently viewing. So when I set it to be the terminal, and when I launched the debugger, the OBS was still capturing the terminal and the mouse movement. So I was saying like, okay, we will edit this and we will make blah blah blah, and nothing was viewing on the screen. And the second time, okay, it works fine, but I did something. I set the capturing device to, or the capturing window to be the debugger, and it didn't capture the menus and the output console and anything. It only captures the debugger, and the conclusion is never use this feature again. Now let's record it for the last time, I hope. Let's move to the debugger, and I will load the application, and as I said 3 times, let's pin this over here. Any good debugger will have or will identify the main function entry, and will make an automatic breakpoint address, and ADB do that, and this is the main entry of our main function, the entry of our main function. Okay, this is unlike the output of JS assembler or GNU assembler or JS, I don't know what they call it, I don't use it. All the numbers here are hexadecimal, so the 0x8 is the Y value, which is 10, stored at RBP minus 0xC, which is the base pointer, minus C is 11, I think. And this is the address where this string is stored, and this is a call to printf to print the string, and this is a call to scanf. This is where the input to our program and output of the scanf function is stored. It's stored at our base pointer minus 10, which is 16 in decimal, and it moved to EAX to be able to apply compare on these operands, because you know you can apply compare on two memory addresses. One of them at least must be a register. Okay, just to prove that I'm not cheating, EAX, we will run the program first. We have a smart option in EDB, which is run to this line, enter a number, we will enter 15, which is F, and now there is another breakpoint here. The value at AX is 1 because the move is this instruction, we will execute it, and now we have F at AX. Okay, we are comparing AX to our base pointer minus 60 minus C. Okay, where is this value? We will jump to the base pointer. It's this address 5AE0, which is this one. It's minus C, so we will count backward. Where 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. This is the A, which is the Y value. Okay, I'll compare them together, and the comparison is true, or if they are equal, we will not jump to this address. We will continue to load the effective address of this string and call poststring to print it, and we will jump to this address, which is A216, which is all it does is a clean exit, as we said. If this is not the case, if they are not equal, we'll jump to this address, which is this one, 820A, this one, that loads the effective address of the string and call poststring to print it, and continue the execution to close the program. Okay, jump if not equal, we can edit it to be jump equal. I said while I was hold on. While I was viewing the assembly of JS, that we can make it unconditional jump. We can make it jump, but it's not. It won't work that way, because if this is jump, the execution will always jump to this address, and this address will print this message. It must be jump if equal, or we can just delete it, or we can put here to NOP instruction, which is no operation, but I won't do this. I will go the easy way. I will make it jump if equal. I've showed you that the operands of compare are valid. This one is the 10 and this one is the 15, but we will print this message because we have edited this instruction. Okay, now we shouldn't jump if everything worked fine, which is we will load this address, and we will pass it to poststring, and we'll print it correct password. Now let's back to the old video. Now what? Let's close all these things and take a look at flock. I wanna mention that this code is written by me 5 or 6 years ago. STD thread wasn't exist yet, so you might wonder why the parameters are void pointers, even if with STD thread you can do things like this. This is the func pointer and the parameter par1 and par2 and so on, but I'm too lazy to do this. In this code we have no f. The encryption and the decryption process is part of the code. No matter what is the password you will enter, the operation will continue to happen. The code don't know what is the password. It has no clue what is your password. I don't know how to deliver it better than this in English, but I think you got the point. Where is the function? Yeah, we are encrypt. First of all, there is a character byte and the referencing of the word pointer and casting it back to a struct, and everything happens here. We have a while, and you might thought like I mentioned that in the get repo of this project. Okay, I will use while instead of f. While will produce the same code, but you are doing good. We are reading the binary file byte by byte and messing with the byte. We are literally destroying the byte. We are altering its value, but with the exact, hold on, let me connect the charger of my laptop. Okay. We are editing its value, but we can retrieve it back. Why? Because of these constants. 13, 8, 20, 13. It's a date. I won't say what date is it, but or what it belongs to, but it's okay. I just wanted to say that. We have two macros, one for the decryption without a password or a custom encryption key, and one for a custom encryption key, which is enc key. If enc key equals UD, which is the use default, the new byte will be encryption. This will be replaced with byte, no matter what value is it, and some constant number, because this number will evaluate to a single number in the compile time. Otherwise, it will be custom encryption that involves enc key in the process, and that's it. The application done. And no, we should discuss the decryption process. Here for the decryption we subtract, and for the encryption we add. It's really simple. The code is simple, but the concept, I think it's great, or at least I think it's great because I made it. I won't make it long. Thanks for watching this video. If you found it useful, please consider subscribing to my channel and giving me a like and a comment, because you are the only reason I make videos. Bye.